This is problem 1A from Linear Algebra Done Right, section 1C. Feel free to pause the video and give the problem a shot, and keep watching to see how to come up with the solution. Okay, so to be a subspace, what three conditions need to be met? It needs to have an identity. It needs to be closed under addition. And it needs to be closed under scalar multiplication. Closed under scalar multiplication. Okay, so let's look for the identity first. What vector can we add to this and not change it? We can add 0, 0, 0. So I'm going to let the identity be equal to that. And we need to check if this vector satisfies this condition here. Does it? Well, yeah, 0 plus 2 times 0 plus 3 times 0 is equal to 0. So yeah, we can let this be the identity. Now we need to check if it's closed under addition. So we need to take two vectors and add them and see if it still satisfies this condition. Okay, so I'm going to let u be equal to a1, a2, a3, such that a1 plus 2a2 plus 3a3 is equal to 0. And I'm going to let v be equal to b1, b2, b3, such that b1 plus 2b2 plus 3b3 is equal to 0. So we're going to add them and check if this condition is still met. So u plus v is equal to, so it's going to be a1 plus b1 plus 2 times a2 plus b2 plus 3 times a3 plus b3. And this is equal to how much? Well, we added this and this, and that's going to be equal to this plus this, so 0. So yes, it satisfies this condition. So it is closed under addition. Is it closed under scalar multiplication? So this time we're going to be taking a scalar from f, and we're going to be multiplying u with the scalar. So lambda times u is going to be equal to lambda a1, lambda a2, lambda a3. And we need to check if this satisfies this. Does it? Well, we know that a1 plus 2a2 plus 3a3 is equal to 0. If we multiply both sides of the equation by lambda, what are we going to get? We're going to get lambda a1 plus 2 times lambda a2 plus 3 times lambda a3 is equal to 0. Okay, so that means this condition is met. Yeah, so basically it comes down to how can I manipulate this equation in order to check that this satisfies this. And I just multiplied by lambda in order to get it to look like this. Okay, so now that we've done our exploring, we're ready to formalize our proof. Okay, so let's write out the proof. Okay, I'll just put this here. Okay. Let 0 be equal to 0, 0, 0. Then for all vectors v belonging to S, v plus 0 equals v. Since, we're going to put this in now, 0 plus 2 times 0 plus 3 times 0 equals 0. 0 is in S. So 0 equals 0, 0, 0 is the identity. Now we need to write it out for closure under addition. Okay. S is closed under vector addition. For all vectors u and v belong to S, where I'm just going to copy this real quick. U equals to A3 such that A1 plus A2 plus 3A3 equals 0, and V equals B1, B2, B3 such that B1 plus 2B2 plus 3B3 equals 0. We have, we're just going to copy this. U plus V equals A1 plus B1 plus 2 times A2 plus B2 plus 3 times A3 plus B3. And that's equal to how much? Well, that's 0 plus 0. Okay. So since U plus V satisfies this condition, we can say that U plus V belongs to S. So that's why it's closed under vector addition. Okay, now we need to show that it's closed under scalar multiplication. So S is closed under scalar multiplication for all vectors U in S with U equals A1, A2, A3, and all scalars lambda belonging to F. Lambda U is going to be equal to lambda A1, lambda A2, lambda A3, and lambda A1 plus 2 times lambda A2 plus 3 times lambda A3 is equal to 0. So, lambda U belongs to S. Okay, and now we just need to say, since it has an identity, is closed under vector addition and is closed under scalar multiplication, that it is a subspace. Since S has an identity is closed under vector addition and is closed under scalar multiplication, S is a subspace of F cubed.